Let's look at inverse trigonometric functions integration. Here we know that when we differentiate sine inverse of x, we get 1 by square root of 1 minus x square. Okay, when we differentiate cos inverse of x, we get minus 1 by square root of 1 minus x square. When we differentiate tan inverse of x, we get 1 by 1 plus x square. When we differentiate cosec, we get minus 1 by the square root of x square minus 1, and we get absolute value of x here. So that is cosec. Now d by dx of sec inverse of x is equal to 1 by magnitude of x square root of x square minus 1. And finally, when we differentiate cot inverse of x, we get minus 1 by 1 plus x square. Now, generally speaking, when we integrate this, we should get this, right? Similarly, when we integrate this, we should get this, right? So that its differential is this. But that happens only in three cases. That is in case of sine, in case of tan, and in case of sec, right? So keep this in mind, because in this session we are going to focus only on these three. In a later session we will look at the others. Okay, so let's take it one by one. Integral of 1 by square root of 9 minus x square dx. Now, the closest is this, right? Square root of 1 minus x square. The only thing is here instead of 1 we have 9. So we need to take out that 9. So 1 by square root of 9, if we take it out, we get 3. Square root of this becomes 1. And x square needs to be divided by 9, but which can be written as x by 3 square dx. Right? Now, this 1 by 3 can be taken out, and you can do it step by substitution, by saying u is equal to x by 3. That means x will be 3u. If we differentiate u equal to x by 3, we get du is equal to 1 by 3 dx, which means dx is equal to 3 du. Okay, so let's see what happens here. 1 by 3 we have taken it out, so we get 1 by square root of 1 minus u square, and instead of dx we write 3 du. Now here 3 and 3 cancel out, and we are left with 1 by square root of 1 minus u square du, which is exactly the form we needed. So we know this would be sine inverse of u, and if we reverse substitution we do, we get sine inverse of x by 3 plus c. Okay, let's look at the second one. Integral of 1 by 64 plus x square dx. We have to remember these forms and see which one matches the closest. So 1 by 1 plus x square. So we have to take out 64. So let's do this. Let's say 1 by 64, we take it out, right? So 1 by 64. Here we get 1 plus, now 64, it should be x square by 64. So which we can write it as x by 8 square dx. Now let's Do substitution, let u be equal to x by 8, which means x is equal to 8u, right? And if we differentiate, du becomes 1 by 8 dx, which means dx is equal to 8 du. So what do we end up with? We end up with 1 by 64 integral of 1 by 1 plus u square, and dx is 8 du. So 8 du. So here cancellations occur. So we end up with 1 by 8 integral of 1 by 1 plus u square du. So now we have it in this form, and that is nothing but tan inverse of x. So here it will be 1 by 8 tan inverse of u. Reverse substitution, we get tan inverse of u is x by 8 plus c. Let's look at the third one. We have integral of 1 by x square root of x square minus 25 dx. Okay. Now this one we know it is very close to sec inverse, but here it should be 1. So let's try to bring it to 1. So first of all we have to take out 25 out. So let's take square root of 25. If we take it out, we get 5x square root of x square divided by 5 can be written as x by 5 square minus 1 dx. Yes. Now let's say u is equal to x by 5, which means x equal to 5u. Du will be 1 by 5 dx, which means dx is equal to 5 du. Okay, let's do the substitutions. Dx is 5 du by now what do we have here? We have 5x. X is 5u square root of u square minus 1. So here one of the 5's cancel out, and we are left with this, and here we can take out 1 by 5. We have 1 by u square root of u square minus 1 du, and this we know is 1 by 5 sec inverse of u, or to be more precise we need to make it sec inverse of absolute value of u, and reverse substitution, sec inverse of absolute value of x by 5 plus c. You might be wondering why suddenly the absolute value has come, because here we have an absolute value, and since in our problem we have not been given the absolute value, so what we would do is we would actually provide positive x only, right? So that is why absolute value of x by 5. Now fourth one, integral of 1 by x times x square minus 49 dx. I think you got the idea now. So this is also sec inverse form. So let's see whether we can simplify this to that form which we want. So 1 by we want to take out 49. Square root of 49 is 7. Okay. uh, x square root of x square. Now x square, it won't be x square, it would be x by 7 square, because 49 we have taken out, so we have to divide x square by 49 minus 1 dx, and we do the substitution. U is equal to x by 7, that means x equal to 7u, du is equal to 1 by 7 dx, which means dx is equal to 7d. Let's do the substitutions. Integral of 1 by here dx will be replaced with 7 du. 7 we have here, x is 7u square root of u square minus 1. So 7 and 7 cancels, and we have du by 1 by 7, we can take it out, and we have u times square root of u square minus 1. So this is the form which we wanted. We have got it. So now we just integrate it. We know the integral is sec inverse of absolute value of u. And reverse substitution, we get sec inverse of x by 7 plus c. Okay, for this 7, no, we don't have to put the absolute value. Okay, fifth one, integral of 1 by 25 plus x squared dx. Again, we know that this is tan inverse. So let's bring it to that form. We get 1 by 25. 25 we have taken out. So we get 1 by 1 plus x by 5 square dx. Okay, now let's again do the substitutions. U, let it be x by 5. So which means x equal to 7, not 7. 5u du is equal to 1 by 5 dx, and then dx is equal to 5d. So we get 1 by 25 dx becomes 5 du by 1 plus u square. Actually, we don't require this at all. Okay, so here 5 and 25 cancels, and we get 1 by 5, and integral of this is tan inverse of u. And reverse substitution, we get tan inverse of x by 5 plus c. Sixth one. Now we might get something pretty straightforward like integral of 1 plus x squared dx. It is, we know, tan inverse of x plus c. Seventh one, integral of 1 by 100 plus x square dx. Okay, here again we take out 100, integral of 1 by 1 plus x by 10 square dx. U would be x by 10, du would be 1 by 10 dx. That means dx is equal to 10 du. So we get 1 by 100 integral of 10 du by 1 plus u square, which gives us 1 by 10, and the integral of this is tan inverse of u, and reverse substitution we get tan inverse of x by 10. Integral of 1 by x times square root of x square minus 100 dx. Again, it is secant inverse. If you are very sure, you can directly write it, right? Because this will become x by 10 square. So you can directly write it, but I'm going to do it step by step. So this would be what? We have to take out 100. So let's take out 10. That is square root of 100. Integral of 1 by x square root of x by 10 square minus 1 dx. U is equal to x by 10. That means x is equal to 10u. Du is equal to 1 by 10 dx. That means dx is equal to 10 du. 1 by 10. Integral of dx is 10 du. X is 10u square root of u square minus 1. So 10 and 10 cancels, and we have 1 by 10 integral of du by u square root of u square minus 1. And this integral we know is 1 by 10 sec inverse of absolute value of u, which is going to be 1 by 10 sec inverse of u is x by 10. So magnitude of x by 10 plus c. Look at the ninth one. The ninth one is integral of 1 by 81 minus x square square root dx. We need to take out that 81. So let's take it 1 by 9. We get 1 by square root of 1 minus x by 9 square dx. Okay. So now what happens? U is equal to x by 9. So du is equal to 1 by 9 dx. That means dx is equal to 9 d. So let's do the substitutions. We get 1 by 9 integral of 9 du by square root of 1 minus u square. 9 and 9 cancels, and 1 du by square root of 1 minus u square is sine inverse of u, which would be sine inverse of x by 9 plus c. Let's do the 10th one. Integral of minus 1 by square root of 25 minus x square dx. Again, if here we can take minus out, so we get 1 by square root of 25 minus x square dx. To bring it into the form that we are familiar with, we take out 25, so this becomes 1 by 5, 1 by square root of 1 minus x by 5 square dx. So here let's do substitutions. Let's say u is equal to x by 5. So du is equal to 1 by 5 dx, which means dx is equal to 5 du. So this becomes 1 by 5. Dx is 5 du by square root of 1 minus u square. 5 and 5 cancels out. And we know that this integral, that is 1 du by square root of 1 minus u square, is nothing but sine inverse of u. So minus sine inverse of x by 5 plus c. So, remember in the beginning I said that we are going to focus on only sine inverse, tan inverse and secant inverse. Now, as per the pattern, you might expect it to come to cos inverse of x, but it actually comes as minus sine inverse of x. So you need to be careful here. Let's do the 11th one. Integral of 1 by square root of 5 minus x square dx. Okay. Now first we have to take out square root of 5. So this becomes 1 by root 5 integral of 1 by square root of 1 minus x square by 5 dx. Okay. So now square root of 1 by square root of 5 integral of 1 by square root of 1 minus, and both numerator and denominator we have to convert it into a square. Numerator anyhow is a square. So x square by square root of 5 square, we can write it like this. So this becomes 1 by square root of 5 integral of 1 by square root of 1 minus x by root 5 square dx. And now we do the substitutions. U is equal to x by root 5, which means du will be 1 by square root of 5 dx, which means dx will be equal to square root of 5 du. So this becomes 1 by root 5 integral of, after substitutions we'll get dx is root 5 du by square root of 1 minus u square. Okay. Now root 5 cancels, and we are left with du by square root of 1 minus u square. And this we know is equal to sine inverse of u, which is equal to sine inverse of x by 5 plus c. Okay, so that was the 11th one. 12th one, integral of 3 by square root of e minus x square dx. Remember, e is just a constant, right? So we need to take out e. So to take out e, we will write it as 3 by square root of e. So here we'll be left with 1 by square root of 1 minus x by square root of e square x. So now we can take u is equal to x by square root of e, du would be 1 by square root of e dx. That is dx is equal to square root of e du. So now the substitutions. So 3 by square root of e, integral of 1 by square root of 1 minus u square times dx is square root of e du. Square root of e, square root of e cancels, and we have 3 times integral of 1 by square root of 1 minus u square du. And this we know is 3 times sine inverse of u, which is equal to 3 times sine inverse of, what is u? U is x by root e, x by square root of e plus c. 13th one, integral of 7 by pi plus x square dx. This would be 7 by pi integral of 1 by 1 plus x square by pi dx. And this can be written as 7 by pi integral of 1 by 1 plus x by root pi square dx. So now we can write u is equal to x by square root of pi. So du is equal to 1 by square root of pi dx, which gives us dx is equal to square root of pi du. So now let's do the substitution. 7 by pi integral of dx is square root of pi du by 1 plus u square. Okay. Now square root of pi, we can take it out. Integral of 1 by 1 plus u square du, which is equal to 7 square root of pi by pi, and this is going to be tan inverse of u, which gives us 7 by, we can write this as, if we rationalize the numerator, what do we get? We get square root of pi by pi times square root of pi times square root of pi, right? So we are rationalizing the numerator. Tan inverse of u is x by square root of pi. So now here what happens? This becomes 7 pi by pi square root of pi. This pi and pi cancels, and we have tan inverse of x by square root of pi. So our final answer is 7 by square root of pi tan inverse of x by square root of pi plus c. So that is that. So now let's go to the 14th one. Integral of 7 by x times square root of x square minus 5. So here 5 we have to take it out. right? So let's take 7, and in the denominator let's take square root of 5 out. We are left with 1 by uh, x as it is, square root of x square by 5 minus 1, right, dx. And this can be written as square root of 5 integral of 1 by x times square root of, now we want the denominator also as a square, so x by square root of 5 square minus 1 dx, which gives us 7 by square root of 5 integral of, now let's do the substitutions. Let u be x by square root of 5, du becomes 1 by root 5 dx, which means dx is equal to square root of 5 du. And here x becomes root 5 u. So here dx is there, so square root of 5 du divided by x is square root of 5 u times square root of u square minus 1. Here square root of 5, square root of 5 cancels, and we have 1 by u times square root of u square minus 1, and we know this. So 7 by square root of 5, and this is what? This is going to be sec inverse of magnitude of u. Okay, because now we substitute back u. So sec inverse of u is x by root 5. So x by square root of 5 plus 6. So that is the integral. Okay, let's look at 15th one. Integral of 2 by 4 plus 9x square dx, which gives us 2 by 4 integral of 1 by 4 we have taken out, so we have 1 plus now 9x square by 4 dx. So this becomes 1 by 2 integral of 1 by 1 plus, and we have to convert it into a proper square. So 3x by 2 square dx. Now substitutions. Let u be equal to 3x by 2. Du would be 3 by 2 dx. That means dx is equal to 2 by 3 du. And do we require x? X we don't require. So we can proceed. So 1 by 2 integral of 2 by 3 du. So du and 2 by 3 we can take it out. So 2 cancels. Du by 1 plus u square. So we are left with 1 by 3, and 1 by 1 plus u square is tan inverse of u, which is 1 by 3 tan inverse of u is 3 by 2 x plus c. 16th integral of 2 by 5 plus 3x square dx. Okay, so 2, let's take 5 out. We are left with 1 by 1 plus 3 by 5x square dx. This we want it as a perfect square. So 2 by 5 integral of 1 by 1 plus, let's convert 3 and 5 also as square. So square root of 3 by square root of 5 x square dx. So u will be square root of 3 by square root of 5 x, and this can be rewritten as, if we rationalize the numerator, what do we get? Root 3 times root 3 gives us 3, and in the denominator we get root 15x. So let's now differentiate. we get 3 by square root of 15 dx. That means dx is equal to root 15 by 3 du. So let's write this. Root 15 by 3 can come out. Integral of 1 by 1 plus u square. So this is 2 by 15 square root of 15 integral of, no, now we can actually integrate it. So this becomes tan inverse of u. And let's rationalize the numerator. If we rationalize, we don't have to actually, but root 15 seems fun because, okay, uh, basically the objective is, one second, I'll just, if we substitute back u, we get root uh, 3 by root 15 x, right? So something similar we want it here also. So let's rationalize it. So 15 by 15 root 15. So 15 cancels. We have tan inverse of 3 by root 15 x. So which means we have 2 by root 15 tan inverse of this 3. We can actually take it down. So we can write it as 1 by 3 root 15, or we can leave it as 3 by root 15x, and plus c. Now 17th one. Integral of 3 by pi by 2 plus 5x squared dx. 3 comes out, pi by 2 comes out, and we have 1 by 1 plus 5 by pi by 2 x squared dx. So this becomes 6 by pi integral of 1 by 1 plus, this becomes 10 by pi x square dx. 6 by pi integral of 1 by 1 plus square root of 10 by square root of pi x square dx. Now u is equal to square root of 10 by square root of pi x. So du would be square root of 10 by square root of pi dx, and dx would be square root of pi by square root of 10 du. Okay, so now let's do the substitution. 6 by pi, this square root of pi by square root of 10 can be taken out. So square root of pi by square root of 10 comes out. Integral of 1 by 1 plus u square dx, which gives us, this becomes 6 pi by pi square root of pi square root of 10. Integral of, no, we can now actually integrate it. So this becomes tan inverse of, now pi and pi cancels, and we have 6 by square root of 10 pi times tan inverse of u is square root of 10 by square root of pi x. If we want, we can take it a little bit further by rationalizing the numerator here. So what do we get? We get 10 by square root of 10 pi x plus c. Finally, 18th one. Integral of 3 by 4 plus x to the power of 2 by 3 dx. Okay, 3 by 4 we take it out. We are left with 1 by 1 plus x2 by 3 by 4 dx. This becomes 3 by 4 integral of 1 by 1 plus, we have to, this is a square, this can be written as 2 squares, so x to the power of 1 by 3 by 2 square dx. So u will be x to the power of 1 by 3 by 2, and du would be 1 by 3 times 2, and this will be x to the power of 1 by 3 minus 1, which gives us 1 by 6 x to the power of minus 2 by 3. So that means we can take it down, x to the power of 2 by 3 and dx. So if we move it around, we get dx is equal to 6x 2 by 3 2 by 3 du. Now the thing is, we want this x also to be in terms of u. So what do we do? This we can say 2u equal to x to the power of 1 by 3. So if we want x to the power of 2 by 3, what do we do? Square. So 2u square du, which gives us 6 times 4u square du, which gives us 24u square du. So now let's do the substitutions. 3 by 4 integral of dx is 24u square du by 1 plus u square. Okay. So now uh, uh, we can take out this 24 out. So 4 uh, 4 6 24. So 18 comes out. We have u square du by 1 plus u square. Now if we actually divide it, u square by 1 by u square, what do we get? We get 18 times integral of 1 minus 1 by 1 plus, and we know we can take it integrated term by term. So 18 integral of 1 du minus 18 times integral of 1 by 1 plus u square du, which gives us 18u minus 18 tan inverse of u. Now let's do the substitutions. What is u? U is x to the power of 1 by 3. So 18 times cube root of x by 2 minus 18 tan inverse of cube root of x by 2. 2 nines 18. So we have 9. We can write it as 9x to the power of 1 by 3 minus 18 times tan inverse of x to the power of 1 by 3 by 2 plus c. That is the okay. So that is inverse trigonometric functions integration. That's it. Bye.